and share my screen. Make sure you take the quiz by end of day. Next time I set it up, I'll probably set it up as you must take it before like 8, so that way I can get the attendance in that night. But right now I have it set up for end of day, but make sure you take it by 11:59. Otherwise, I will not reopen it for you and you'll get a 0. So let me get started.
Can we go ahead and set the lab if we already have it finished?
You can submit, if the lab one you already have submitted, that's fine.
Okay.
But remember, you only have 2 attempts, and so you want to make sure it's correct.
And just so I'm understanding this correctly, are you wanting a user input, or are you wanting us to use the sample run?
We're going to go over the lab after lecture.
Okay. Okay.
So let me start sharing my screen and get everything set up, and then we'll go. Share content, share application screen. When you can see my screen?
See it now.
Let me get up Blackboard just to answer some Cin's questions. When it comes to recording lectures, I send them off someone to post them because I guess he makes the file size smaller. If you go to recorded lectures right here, if you click on any one of these, I put this main link on, I'll probably remove these 2. If you click on the main link, you will see all the lectures. You could have clicked on either one. If they're not posted here, you can easily go to Blackboard Collaborate Ultra and do the manage recordings, and once I stop recording, it usually takes a few minutes to be able to download here. But they are usually here first before they get published the other at YouTube. So today is Wednesday, September 9th. We will cover chapters 1 and 2. I'm sorry, 1 and 2 quiz, you have it today, and we're going to go over chapter 3. Chapter 3 is our last of our formatting chapters, and then we can really have fun because then we cover logic and then functions and looping in the upcoming chapters. These 3 chapters are kind of like, this is how you do input, this is how you do output, and so forth. Then we will look at your lab 1. Your lab 1 is officially assigned today, and it's due by September 16th by 11:59 end of day. Any questions on when it's due? It's due at 11:59. If you do not make that day and you get a 0 and you don't turn anything in, or you don't do any part of it, you just turn your name in the sheet of code and you turn it in, you get a 0. That 0 stays with you, and I drop another grade. So do not mess up on these beginning labs. But remember, I drop your lowest attempted lab. So any questions on that before you go to a lecture, and then we look at our lab, and then we'll discuss what I expect with your lab. Okay? Chapter 3. Let's see, slideshow. Just like we did with the cout object, the cin object is used to read data into a variable. It's a cin object. Same thing if you do a cin dot, you see all the member functions that you can use. So it's just not a primitive data type like an int, float, char, not a string. String is not a primitive type, but all those other ones that we talked about, int, char, float, double, long, those are primitive data types. String is not. The cin object reads input from standard input and reads it into a variable. You must, like a cout requires the iOS stream. It's used to get input from the keyboard. Notice the direction operators is pointing the opposite way. Think of it as pointing to the variable that it's reading into. Right, like right here. Anytime you do text-based programming or even UI, you want to prompt the user what they need to enter. So what is the length of a rectangle? You want to prompt them and then read in length. notice you have cin, the redirection operator is pointing to the variable name. Whatever the user types, it's always going to try to be converted to the data type of that variable. So if they type in a character, remember that character is going to try to store as an int. So remember that. It's no matter what it is, it's always whatever type the user enters, it's always going to try to store the data type of that variable. Cin converts data to the type that matches that variable. That's what I just mentioned right here. So if you want to enter them a float or a double, then make that int a double. But if they type in, let's say 121.1 inches, it will not capture the 0.1. You want to always display a prompt when asking the user for something. Even on the form, you would see you being prompted, enter your name, enter your email. Whatever you need to use it to enter, always give them the prompt. Or if it's UI case, a label. You can use cin concatenately, like doing cin height and width, but there must be a space between it. I don't recommend doing this because it leads up to more errors. Because what about the user types in width and not the height, or they don't put the space in it? This can come up with problems. So for right here, they entered, let's go do changes to, where's it going to go? Like right here, they're ending length and width on the same line, but they put in space. Nothing's wrong with it. A lot of times this can be problematic because what about they don't put a space, or they put a dash, or they don't enter it correctly? You always want to minimize potential problems. Any question on this? You can bring this up and you can concatenate if you have another one in depth. Right here, it doesn't matter what data type you want to store it in, it can still use concatenatedly. Whatever the user types in for whole number is stored in whole. If they enter a fractional part and letter, it's going to read in from left to right, like you're reading a book. And if everyone knows what NL is, it goes to the next line. So all this chapter is reading in characters and starting to display some of your format on your output. Mathematical expressions can create a complex expression using multiple mathematical expressions. You have some for your labs that you're going to do today, not for your in-labs. An expression can be a literal, a variable, or a mathematical combination of constants and variables. For example, you have a literal right here. All this is being capital, which screams out it's a constant defined somewhere, and you can have a variable. This is defined as an area right here. And you can put border is area if you want right here. Why do you think doing it this way is not preferred compared to doing it variable here, area, and then displaying this area down here? Can someone give me a reason why you would want to do the top one instead of the bottom? Or did I not make that question clear? You can put the calculations right here in the cout statements and it's going to calculate fine, but would it be recommended to set this to a variable name and then use the variable name here?
I think so, yeah.
Which one? Which one would be preferable and why?
Putting in a variable, I think because, I believe because would it make your code more easier to read?
Not necessarily easy to read. Potentially it could because you says like this is the area is and then you display area, but they know the no, because it could be a little bit easier to read because you say this area is and then the area instead of having the formula. Having it as a variable name right here you can use it throughout your code. What about if you wanted to see out the area again or display it later on? If you constantly have it calculated right here, you're going to have to copy and paste these calculations and do it each time. But if you calculate it once, you have it in this variable, and you can just pass that variable along. Does it make sense?
Yeah.
Because these would be performance hits because each time you have to do a calculation, but you can just pass in the variable and use it around, and you can pass it on to functions. Just keep look ahead.
Wouldn't the second option reduce the amount of space that's used?
No, what I said is processing time, not space.
Okay.
Each time this, it's going to take a calculation hit on this, but if you only do it once, you're just passing the variable around. You're not recalculating everything again. In an expression with more than one operator, evaluate in this order. Unary operators, which were discussed more in the next chapter, chapter 4, the increment and decrement. Then you got the multiplication, divide, and modulus, and the addition, subtraction. Just like in math, we have the order of operations. So if you need to change the order of any kind of calculations, use parentheses. We're not going to go over all those, but with the order right here, you have 5 plus 2 times 4. In math, same thing. You would do the multiplication first, and then you would add 5. But when you change it with parentheses, it's going to be different if you want 5 plus 2. Put these in parentheses, order what should be changed. So be very careful of when you write your mathematical expression that you validate your results. Do not assume that the computer is going to always calculate it correctly. Always calculate your results. When you're writing your code, calculate them and validate that those results are correct. Do not assume the computer's calculation is correct because of order operations. You might see it one way, the computer might see it another. This is kind of incorrect. Unary operations is, let me see if I have, I don't know. Unary operations, I'll show in a minute. It's like x plus plus. Those are usually same thing, left to right. These you read like you're reading a book, left to right. Parentheses can be used to override the order of operations. For example, if you have 2 plus 2 times 2, like right here, the calculations will say, do this multiplication first, 4, add 2, and then subtract 2. So then you get 4. But if you change your parentheses right here, now you're adding these parentheses right here, 4 times right here, and then you're going to do right here 2 minus 2. Right, that doesn't seem right. Oh wait, no, I'm sorry, I did that wrong. 2 plus 2 times 2 is 4, minus 2 is 6. Just I'm saying, keep your parentheses and know the order that you would expect it in. If the order is correct or you just want clarity, always use parentheses. And this is just more expressions with math and using parentheses. So all I want to reemphasize is when you write your equations, validate your responses, make sure they're correct. If they're not, put the parentheses in the place that you want them to make sure the proper order. If not, use parentheses just for clarity. Some mathematical expressions right here. Area, you cannot write area like in math, length times width. You have to write it as L times W. You have to spell it out. Area, we also have a PAL function. PAL, this is the variable, and it's raised to the second power. Same thing with parentheses. These are the slope-intercept form. You cannot write it like this, but be careful. Y2 minus Y1 in parentheses over the difference of the x's. If you do not have these parentheses, you're going to do y1 divided by x2 and then do the rest, y2 minus x1. So be careful of the way you write your code. There are so many times students come up and say, my results are not correct. And I always say, validate your equations, validate your responses. Here's the mathematical expressions. And here's in English, 6 times b. And here's the C++ equivalent, or C, or even Java equivalent. You cannot write it like this in the compiler. You must write it like this. Any questions so far? When you mix apples and oranges, type conversion happens. We talked about this briefly in the previous chapter. Operations are performed between operands of the same type. Let me repeat that. Operations are performed between operands of the same type. If not of the same type, C++ will convert one to be the type of the other. This can be compacted the results of calculations. Here's your hierarchy of data types. If you have an unsigned int and then you're using a float, multiplying these or adding them, the calculations will be a float. Type coercion is the automatic conversion of an operand to another type. Promotion is to convert to a higher type. There's another way of doing it. Instead of doing what we just did before, when you did an int times a double, we can cast data types to be a different data type. And demotion is when you convert one to the lower. Normally, you do not do this. Usually, I see this in students in warning messages, and that's what I'll be looking for, is when you take, let's say, a double, and you automatically put it to an int. You lose percentages. You lose precision, not percentages, precision. Char short and unsigned short automatically promote to an int. Normally, you do not worry about calculating a char. Short, unsigned int, yes you do, but most of the time you don't use those. I hardly see people use short, unsigned. I normally always see if they're going to use an int, they use an int. When operating on values of different data types, the lower one is promoted to the type of the higher one. That makes sense. The coercion goes up. When using the, what do we call this operator? What does operator? Assignment operator. The type of the expression on the right will be converted to that of the left. This was, remember in chapter 2 when I had that spreadsheet up? Let me see if I can pull that up. Backboard. Number layout. These right here. When I said you're at the highest value and you add one, and then it switches to the negative 327, overflow, and then you flip it the other way, it's the underflow. That's what they're talking about right here. Play from current slide. Occurs when assigning a value that is too large, it overflows, or too small, it underflows to be held in a variable. Variable contains values that is wrapped around a set of possible values. Different systems may display a warning or an error message stopping the program or continue execution. This is based upon the system, and sometimes in like IntelliJ and in Eclipse, some of those IDEs, you can customize your warning messages and error messages. So sometimes, not all cases, the compiler will catch this. So just be careful of the ranges of the number values that you can use. Typecasting is converting one data type to the next. Used for manual data type conversion. So for example, if I want to convert y2 and y1, if this is both integers, and I want to cast the result of this to a double, this is what the C++ preferred way of doing it is. Using the keyword static underscore cast, angle brackets, the data type that you would want, open and close parentheses, and the variable you want. Actually, I hit my magic mouse and it moves. Let me go back. Does that make sense? You are converting, if this is an int, you're casting just this one to a double. This one down here of x2 and x1 are ints. This calculation is all going to be converted to a double and then assign it to m. So right here, they're taking the char and they're casting it to an integer. So the key word on doing the proper static cast in C++ is doing static underscore cast, the data type in angle brackets, and the variable name. Here's an example. How many books have you read? She read 30. How many months will it take for you to read those? So they're taking number of books, which is 30, divided by number of months, 7. Both these are ints, but they're casting one of them. With that being said, if I wrote something, let's say like this, so much easier on, what about if I wrote this instead? Static cast, let me open up Word, it's better. Static cast books over month. Change it to double. I think that would be problematic. Let's say if I have 1, if books is 1 and month is 2. Do you think that would be problematic? If books is both ints, books and month are both ints, and then I do this.
So you're saying if you cast them both to doubles, would it be a
Yeah,
problem?
because right now, in this case, yes, it's just going to be 1 divided by 2, which is what?
5.5.
No, but we're talking about 1 and 2, I said are both ints.
Oh, if they're integers, yeah. I'm sorry. I guess I missed what you said.
They're both ints. So now if I take that and I do a static cast, and that one, the resultant would be 0.0. But if one of them is cast, then you're fine because now you have 1.0 divided by 2, then you have your 0.5. So be careful on what you're casting. Be careful. Does everyone see this trap right here? Everyone good? So in this case, they're only casting 1. Someone speak up?
No, I was just saying, yeah, like, I
Okay. Current slide. This is in most other languages, Java, and my preferred method is because I like to type short stuff. I don't like to do a lot of typing. So instead of doing static cast, you can just use these parentheses right before the variable and just do an int and what you want to cast it to. So know which way you'd want to do it. I'm not picky on it. Just know that when I say C++ supported, I expect you to write it static cast this way. If I don't specify casting, cast however you want, but know the difference. I haven't researched why is that preferred, nor do I care, but know the difference. This is the preferred way, doing static cast. The other way, int. You can combine multiple assignments operators, saying that 5 is going to be assigned all of these, and you can put parentheses. The reason most of the time you would want to do those if you want to wipe away everything to 0. That's the time that I mostly see it, is when you're doing the calculations over and over again or in a loop and you want to wipe things out. You would put it cascading as this is equal to that, X assignment to Y, assignment to Z, assignment to 0. So that way it cascades down. So 0 gets assigned to Z, 0 gets assigned to Y. You're just wiping out. But you can do multiple assignments on one line. Now we'll go to different shortcut methods. If you want to just add 1, or it could be 2, to a variable and assign it back, this is the way you would write it. Sum plus 1, assign it back to sum. It could be 1, 5, it could be 100, whatever, or another variable. It doesn't matter. This is the way you can combine assignment statements. So they created a short way of writing it. So this is just showing you examples of taking x plus 4, x minus 3, all these different operators we talked about, and now they're just going to make you a shorthand equivalent of writing it. Instead of saying sum plus 1, sum times 1, sum modulus 1, or whatever, all you do is take the operator that you want to use first and then the assignment. That's the way I always remember how to do it. Take the variable, the operator that you'd want, and then you're going to do the assignment. It's not the assignment and the operator, it's do the operator first and then you assign it. These two are equivalent. Whichever how you want to write it, don't care. And this is showing you an example of multiple ones. If you want to do subtraction, multiplication, division, or modulus. Formatting of the output. Remember that you did the previous lab, what was it, the restaurant bill? Some of the calculations didn't look right, like we had a change of 0.353 or 0.3 and no trailing zeros. This is how we are going to correct it. Formatting your output using size, position, and number of digits. You are required to use another preprocessor directive, io_manip. The way you can easily remember it is input-output manipulation, because that's what we're going to do. We're going to manipulate our output. String manipulators are used to control how an output field is displayed. The first one we see is set w parentheses x. This is used to write in nice column forms, printed in a field at least x spaces wide. We'll expand if need be, but this is what's going to help you to create a nice tabular table if need be. Here's an example that they're using set w, all these throughout, and it creates a nice column table. These are the ones that you're going to use quite a bit. I always use them in conjunctions at all the same time, but they might have different behaviors if you use some but not use them all. So this is a good time to practice. Fixed is a used decimal notation for floating point values. Remember in Chapter 2 that says, by default, even though we don't see it all the time because our numbers were not that big, that floating and double points are default stored in scientific notation. So if you wanted to force that to be in a decimal form, you would use fixed. Set precision, when used with fix in the printing point flow notation, x digits after the decimal. So if you use fix, it's going to say, hey, I want this no longer to be in scientific notation, but I want 2 decimal places to the right, so I'm going to use set precision 2. So anything dot, I want 2 decimal places to the right. But it won't give you, if the change is, let's say, 20 cents, 30 cents, it may or may not give you that ending 0. That's where show point comes in. Show point always prints decimals for floating point values. If you use things interchangeably, some of the results might be erratic. I always use them. If I'm going to use fix, I'm going to use them all. Here's the values right here, grabbing in the cells for days. And what they're doing is now setting set precision to be 2 and fix. So they have this nice formatting money-wise right here to say, here's the value I always want 2 decimal places to right, because I'm using fix and I'm using set precision. And this is a nice and testable question right here to what we just all talked about. What's set with? Fix, show point, and set precision. Know what these do, along with left and right alignment. We mentioned strings in the previous chapter. Strings, remember, you use the preprocessor directive, string. They're not primitive data type. They're not part of the C++ language. That's why you use a preprocessor. And they have quirks with working with cin. Using cin with the operators to input strings can cause problems. They do cause problems. Let me correct that again. If you are not familiar on how strings work, they will cause you problems. They will. It passes over and ignores any leading white spaces, characters, space, tabs, and line breaks. So if you do, I have, I have it, could have just done it here, iOS string. Include string using namespace. What they're saying right here with string text. My variable name. And then I do a cin. Let me first do cout. Please enter some text. Cin text cout, and I'll put some new lines. And then cout my text. Notice on my cin, I have it pointing direction the other direction. What they're saying right here is build solution. Debug, start with the debugging. I put a whole bunch of spaces. Hello. Notice it doesn't put all the spaces in there. It only captures up to the first non-space and then reads in. That's the question right there, or that it's saying right here. Using cin operations to input strings can cause problems. It passes over and ignores any white spaces, characters, spaces, tabs, or line breaks. If you want to capture the entire line, you would use getLine. now it puts the spaces in. Does this add clarity to those statements? This is a good chapter to start practicing with some of those, because right now they want to do Kate.Smith. Remember, if you didn't do get line, cin would only read up to Kate and this space. It will stop right here. So to read the entire line, you must use get line. To read in a single character, you can just read in, strike any key, and then prompt in with the cin character. There's nothing wrong with that. This right here, cin.get, is the same concept of reading in a single character. Sometimes you use this in console applications to hold the screen, like press it, like you see at the very end, press any key to continue. That's why they're using it right then. Most of the time you don't care what they enter, so you can just ignore it. So this is what, either way you want to do it. They're capturing what the user enters, but sometimes you can just use cin.get and you don't care if they hit enter what's next, because we call that dropping on the floor if you don't care what they do with it. And here's a couple examples of doing cin.get. Cin.get right here reads into characters right here. Press any key to continue. Then they're saying it passes for a second time. This just still overrides whatever's in cin. This stores whatever they enter here. It overrides it here. And this right here, we don't care what they enter. Just hold them there until they hit any key. Mixing cin and cin.get in the same program can cause input errors. And it automatically sometimes can skip over unneeded characters that are still in the keyboard buffer. Yes, this does happen. Let me see if I can duplicate this real quick. Let me see. Visual Studio. cin.get. String.x2. Oh, look. Do you see that? I typed in hello all, and right now it didn't prompt me to enter all that information, did it? It skipped over, please enter some text on the second one. Speaks Windy. Let me see if I can again. Debug. Start without debugging. Hello. That time it worked. But sometimes when you use them interchangeably, it does not. The reason why that sometimes happens is when you do in the keyboard buffer, when you type in hello, you have H in the IR stream, E, LL, O, and then you would have a new line. This new line, though cin sometimes read up to the space or a new line, so sometimes this gets caught in there. So that's why it skips. So be careful with that. To get away with that, to get over that, you use this cin.ignore. And then that will help cause the problem, because it says whatever's in the next keyboard buffer, because remember it said these are objects. So cin, if you do cin.ignore, and I mentioned before, cin, you have all these member functions that you can use. Same thing with cout. You can practice with it. We won't talk a lot about this in this class, but remember these are objects, and so you can use all these things that are predefined for you, such as cin.ignore. Play from current slide. And all this, it says, please ignore the next 10 characters, 10 new lines. So you can configure them. To find the length of a string, like Texas, which is TEXAS, 5 characters, it's going to display, what do you think it's going to display? 5 characters or 6? What do you think it's going to display?
5.
But remember, in the keyboard buffer, you're right, but I'm just saying, remember, when you start doing, like on this, when you start doing strings, you have TEXAS in memory, but you also have that null terminating bit. When you deal with characters, strings, make sure you account for that null terminating bit. It's actually 6. The size of it is actually 6, but when you do the size of it, it only counts all the way up to the null terminating bit. Play from current slide. Just like this is used in math as the addition, with strings, it's the concatenation. It's going to take greeting ones and add name to it and assign it to greetings. And this is the way you can do shorthand. So just like the addition, it has a dual purpose. It's the addition symbol for additions, for numeric values, but now we found out that with strings, it's the concatenation. You append strings to it. Another preprocessor directive that's coming up is CMath. Know that the preprocessor directives are out there. I'm not asking you to write any sine, cosine, tangent, or any of these complex math statements. If you want to do that for your Lab 6, more power to you. Just know that they're out there and that we did discuss them. I'm not going to test you what sine does, cosine, or tangent. Just know that there are other mathematical operations out there, and you need to use the CMath preprocessor directive file. Same thing, there's another one for cstd-lib. This gives you the pseudo random number generator. Ran, used with this processor, returns a random number generator between 0 and the largest number in the compute it holds. So we're not going to go over a lot of these random number generators, but you can practice on your own. Just know that they're out there. cstd-lib is used for the random number generator. This is what we call the hand tracing of a program. As you get familiar with it, local variables are not initialized to a particular value. They are garbage values when you define them. So when you do a hand tracing of a program, act as if you're a program executing a program step by step. And this sometimes helps you resolve logic problems. For example, in this one, right on here, you define all these numbers, 1, 2, 3, 4, and average. When you define these number values right here at the very beginning, this is what later on when you call in Chapter 4 local variables. They are not assigned a value. They're not initialized to anything. If you look at them through the debugger, they have garbage values in them. And if you try to use calculations with them before you assign them, sometimes the compiler will hiccup on you. Just give you a warning message. But as you step through line by line, it's supposed to help you understand what your problem is. For example, enter the first number in here. All these are unknowns. When you do cin and you enter 10, this is now number 1 is 10. The rest are unknowns. Enter the second number, and so forth and so on. For right now, it's saying num1 plus num2, num3 divided by 3, and assign that to an average. The average right on this case is 40. Is that correct or incorrect?
Wouldn't that be incorrect? Because
Why would that not be?
order operations within number one, because it would divide number 3 by 3 and then add it to
Yes,
one.
very good. You're very good. Correct. And so stepping line by line sometimes will help you see that information. That's what they're just trying right here. And this is a case study. We'll just briefly go over it. This is a case of generate crates incorporated build custom design with one crate. You have you have been asked to write a program that calculates the volume, cost, customer price, profit of the crate. I don't see this too many times in the real world. This is what we call a data dictionary, which defines all your variable names. Notice that when these are in capital right here, we see them as constant. So that's why you see the word constant right here. And when we did our in-labs last class period, how we wrote our length, we didn't put this in great detail, what it says, a length variable holds all this, but we started to define our variables and what they meant when we did before we coded anything. So this will help you define some of your variable names and what they should stand for. This is a program design at a high level. Step 1, ask the user to enter the dimensions of a crate. That will be one of your first blocks that we wrote. Get input. Step 2, calculate the volume of the crate, and so forth. That will be block 2. The next one, the cost of building the crate. Step 3, and so forth. You would build this as your flow chart. Here's 1 block, 2 blocks, 3 blocks like we did before, and then you would display your results. We're not going to talk much about the hierarchy because I don't see those at all. And then they started to write pseudocode to do the steps. Each one of these pseudo steps could potentially be a block like we did before. Calculate this or get input, a single action. Ask the user for input, boom, block. Ask the user for 2. And we'll see more of these when you do our in-lab for Chapter 3. This is the page that we did before. What I know, like when you did our restaurant bill. We wrote down all our calculations. And then we went to our program. And this helps you doing these steps, breaking apart, helping you write your code in sequential order as it needs to be. We don't need to go over this entire thing. But does this chapter make a little bit of sense to you? All we talked about is the cin object, formatting of your output, and some of the shortcuts. Yes?
Yeah, it really helped me get the structure of it, like how to plan it out and how to get everything rolling.
Like when you did that flow chart?
Right, yeah. I even used that same website you were using. It's very useful.
Yes, it is. It is. Trust me, it's faster on the board, but it does that draw IO is useful. And we'll use it again on Chapter 3. Hold on, that was my phone.
Yeah, they've even came out with some programs that use that as like another way to code now.
There are things like on Ruby Rose and so forth. When I was doing my undergrad, that they would write pseudocode, and that would help transcribe some of the logic and coding for you. But for the very beginning, writing that flowchart helps. And when students come up and they have problems, and it's like my order doesn't work or my flow doesn't work, especially when you get your angle, when you do chapter 4, when you do the if statements, and the chapter 5, the while statements, and I ask for the flow chart, and we start walking through it. By just walking through it on that flow chart, sometimes students find out the logic problems because you code them on a different branch. So we'll get more and more. But right now, let's go over the labs. The labs should be visible. Here's all your labs that you can do. You can get started on it, get them done early. I have no problems with you. That's why I do not accept late work, because you have all the assignments that you need to do. For getting help, I don't mind helping students that go before, or ahead, but I will not take class time to answer questions regarding future labs. If you want to get help, I'll do emails before class or after class. I'll help you. But I do not want to talk advanced topics for students that are not there yet during class time. So let's look at this one. Can everyone see it right now?
Yes.
Yeah.
So in this lab, we're implementing this C++ program for full credit. Submit your CPP file only through the portal. And we'll see if I can show you right now how to do it later on after we talk about this. I don't know if this formula is correct. Don't know. Don't care. The American College of Sports Medicine recommends that you maintain your training heart rate and aerobic workout. Your training heart rate is computed by this. You don't have to use these variable names, THR minus this, but where age is your age and R is your resting heart rate. Use the formula given above, write a C++ program that reads a person's age and resting heart rate and outputs the training heart rate. Output should look like this. So you're displaying something to the user, enter your age, and prompting the user to say enter your age, and the user is going to enter in a value. Then they're going to enter in the value. Then another screen is prompt going to come up and say enter your resting heart rate. They're going to enter, in this case, 70. Hit enter. Then you're going to display the THR is 161 beats per minute. Remember, your heart rate can only be a whole number, right? You can't have 161.2, 163.1. So make sure you're using the correct data types, it looks correctly, and make sure you don't have any warning error messages saying, hey, you got loss of precision. Because that's all that we talked about was data types, and now we talked about formatting. You're going to name your heart rate, this program, heart rate XX, with this XX being your initials. Remember, right here, my source code is this right here is going to be your heart rate XX in your initials. Remember I said when you create your project, do not name your project heart rate, because someone will, and it always happens every year, that they're going to name this heart rate, and they're going to go inside here, and they're going to go inside here trying to find the source file, and they're not going to grab this, but they're going to grab one of these files, because all these are going to be heart rate if you name your project. And if you submit one of these, you get a 0. Don't cry me a river. You get a 0 saying, I submitted the wrong one. Can that be dropped? No. Your attempts during class period, I can validate to see if I have the file. I won't grade it for you, but for the first couple times, students ask me, I submitted my program. Can you at least validate that you got it correctly? You have 2 attempts to submit your program to me. After that, tough. To submit it, I believe you go into lab right here. Hopefully it's the same way. You browse your computer, right, and you look for the CPP file, wherever it is, on your thumb drive, wherever it is, and you hit submit. Do not save, click save as draft. If you click save as draft, I don't get it. It's another 0. All it shows me on that side, on my side, it says attempt in progress. So do not click on save as draft and say I'll do it later. Either submit it or you don't. In progress, wrong file are considered zeros. Any questions for your lab?
Yeah, I have a question. So after you get done with your program and you save it, right, and you try and reopen it from that source file, why will it not let me debug it again?
Remember we talked about that before. When you double click on your CPP file, Visual Studio will open it, but it will not open it in the correct project. So you have to create a project, and then VM some. And instead of doing create an empty project, instead of going add new item, you hit add existing item and import it in.
Okay, and so that's how you'll actually be able to run it?
That's exactly how I'm going to run it. I'm going to create an empty project and I'm going to say create an empty project, and I'm going to download your file and say add existing, go to my downloads directory and run it.
Okay.
But yes, if you just double click it, let me see if I can demonstrate it right here. Save it so the students can see it. Save it and save this. As you can see right now, let's ignore. I'm able to do the build and everything. All these are enabled. So right now, if I close the project and just go here, double click on your C++, it opens up Visual C, opens my project, but right here, I don't have all those build and so forth. So always open up in a project. Any other questions? Good. No questions? Remember your, let me look at when is your lab due? Your lab due is due
Next week.
next week. Keep an eye on this, because this is with online classes, and this was always a hindrance to me, is when I did my master's, it was strictly online too, that it's up to the student to be adamant about keeping up with announcements and making their assignments turn in. There's no email reminder saying, hey, your lab and so forth is due. If you need help, I'll help you. You can email me your labs. I can help that way too. If not, we can create a separate sessions and we can look at it too. Unfortunately, since we're all online, if you have your flowchart, take a picture of it in writing or use that Draw.io website that I use to draw your flowchart and we can look at it. Other than that, we have to share. But any other questions or concerns?
We don't need to submit our flowchart, correct?
No, only your CPP file is submitted.
Okay.
That's the only thing I'm going to grade. Your flowchart is just for you, or if we need to look at it together to understand where you went wrong. But keep an eye while you're working through these labs on the due dates, and then lab 6 is your choice on what you need to do. I put the requirements in there like it must use X, Y, and Z, but we have to agree on the task that you're going to create your lab before you actually implement it. Because remember, you're going to share your screen and you're going to demonstrate in front of the class. So keep an eye on, like as you do programs, what you think you'd want to do. So any other questions so far? I just want to put that out there because a lot of times, like right here, when it comes to later on in this class, Lab 6 rough draft is due, and this is part of your grade 2. Getting this submitted on time, so when I leave that day, If you don't submit it on that time and we agree on it, you don't get the points. And these are just, they don't have to be perfect, but just an idea. But any questions so far on the way this class is going? Today we did a lecture. Next class period, we're going to do the Chapter 3 in lab. This in lab, I want you to keep. We are going to enhance it next time using if statements. Then we're doing looping, and then we're doing arrays and functions. So keep it. Any other questions or concerns?
Okay.